Hello. Oh, I can't hear you. Can you hear me? Are you muted?
Can you hear me now? No, let me try to check my config here. Can you hear me
I
now?
hear you now.
Hello,
Yep, I hear you.
No, perfect.
It's nice
can
to
you
meet
hear
you.
me?
I'm Serena. I'll be moderating for you today.
Thank you.
Okay.
Um,
Our light is good for the presentation. Okay.
as we have people trickling in, I just want to make sure that I'm introducing you correctly. Is your name pronounced Cleber Paiva de Souza?
Yes.
Great. I just wanted to make sure. And Lucas Sanchez?
Yes. Yes.
Perfect. It's nice to meet you all as we
Your
are
name is
waiting for this to
Serena.
start.
The right way to spell your name, Serena.
Mm-hmm.
Okay, perfect.
Can I go ahead and share the slideshow for the presentation?
Absolutely. Okay, and we'll give people a few minutes to join here.
Okay.
Hey, welcome, Jimmy. Looks like we've got Jimmy Chunga, who's our conference organizer here too.
Oh.
Welcome, everyone.
And it's a pity not to be in person at Salt Lake City.
Yeah, where are you presenting from?
Brazil.
Oh, wow. What time is it for you?
We are, I think that
1 p.m.
3.
For me, it's 1
Yeah,
p.m.
yeah. For me, it's 2 p.m.
It's not too bad then.
Even we are different time zones here in Brazil.
Do you normally fly in for the Salt Lake in-person SaltConf?
Yes, I was
Cool.
in 2019.
I think that's the only one I got to be at in person, and then last year we had the virtual conference as
Yes,
well.
yes. Last year, Lucas presented with another colleague, but virtually, and this year I'm here with Lucas for this presentation.
It's a pleasure to
That's
be
great.
here again.
Well, thanks for joining us. Now that we are at 11 o'clock, let me introduce myself. My name is Serena Jolly. I'm a UX designer at VMware. I've been working on SaltStack for a few years, and I'll be moderating this session today. Towards the end of this session, we're going to spend about 10 to 15 minutes for questions and answers. So throughout the session, if you want to go to the Q&A tab under the session tab on the right-hand side, you can post your questions there. And at the end, I will call on you and invite you to turn on your camera and microphone to ask your questions. And I'll read out the questions, invite you to turn that on. Once the question's been answered, I'll remove the microphone camera for you to make sure that we're able to get to the other questions. Our speakers for this session are Cleber Paiva de Souza and Lucas Sanches. And Cleber is the director and Lucas is the lead software engineer at SSYS Sistemas. Is that right?
Yes.
Yes.
So now that we've introduced you, I'll hand the rest of the time over to you, and we'll pause with about 10 to 15 minutes to get some questions and answers going.
Okay.
Thank you.
Thank you. For us, it's a pleasure to be here. The title of this presentation is being adding workflow approval to Salt. So to introduce myself, my name is Cleber. I'm director at Sistemas, and I'm here with my colleague Lucas. Feel free to present yourself, Lucas.
Hi, I'm Lucas. We are from Brazil, and we are here to bring you this session on adding workflow approval to Salt.
Thank you, Lucas. The next slide. First, to introduce the problem that you are going to discuss in this presentation, we point here uh, um, uh, three topics that we cannot solve directly with salt by itself. That's the problem when we need in some business project to introduce the concept of workflow approval. That's the way that we can control many aspects of requesting changes in infrastructure, requests that some people in the team approve those requests before this going to be applied in production. Another problem that we bring the attention here, missing of persistency, is that actions that was applied salt in the past could not be reapplied in the system. So in our approach, we will show here some ways that we can control that. And also the needs for interaction from operators teams to apply um, in running commands in the infrastructure. So even when we have a tool like Salt, when we need to run or change things in the infrastructure or in systems, we need that someone type those commands on some kind of CIL tool or in Bash to execute those actions on the system. So we have some times of operator teams in running those actions. When this approach that we are show here, we can reduce this time because we can map a lot of repetitive actions and do this directly by ITSM tool. So just to enter in details of each one of those topics, when we talk about workflow approval, we have these demands most of the time in corporate environments. The idea here is that we need to do or apply something in our systems or infrastructure, but we want some way to get a formal approval of someone or a specific team or a specific person before these changes really happen in the environment or in those systems. So uh, when we are working with Salt natively, we cannot do this kind of uh, um, uh, uh, workflow approval because the tool do not have internally ways that we can organize or separate roles in the tool. So we work it, and we show on the next slides how we can connect it as some tools that companies normally use enterprise to uh, 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 to get could I say for free this kind of feature. Um, Another topic that we still have on the workflow uh, is that actions are done in a sync way. Uh, we could not stop the tool waiting for actions that are done in infrastructure, so we keep those in an intermediate database before these actions really go into the infrastructure. Um, the other topic that we have when we talk about workflow approval is the topic about persistency. Um, Salt does not keep historic data for about what was done or what was applied in the infrastructure. So in case we have system reinstallation, um, everything that was done or was applied in those systems need to be reapplied. So you need to check all the history of events and reapply all those actions in the system again. Um, During our work, we organized infrastructure using databases and external pillars that we keep history of all the events that was processed in the infrastructure. This way, if the system is reinstalled, um, all the actions that was applied in the past are again reapplied on those systems. In this way, we reduce rework that need to be done to establish a system to the point that was expected the system to be. And the third topic is about personnel. Uh, when operators, when we have mapped or repetitive tasks in the infrastructure, operators do not be in charge of those actions because um, we show here using ITSM tools that we could create many kind of service requests for actions that was know or mapped or you know how to apply those actions programmatically in the infrastructure. And in this way, we do not need that operators be in charge of applying or executing those commands in the infrastructure anymore. We show how we could have your ITSM directly calling uh, uh, South API and executing those actions in the infrastructure. This way, we are going to optimize the operator's time and freeing operators time for more skillful demands of the business. Um, and also, uh, one of the points that we have uh, uh, noticed with these reductions of time is the problem that we have sometimes about contracting more IT professionals in many countries, as we are going to free your personal professionals time from doing repetitive tasks or mapped tasks. You can use their time for more uh, activities connected to the business. On the next slide, we show here how the approach that we have used to accomplish this workflow approval in Salt. Um, we selected for this presentation the usage of Jira as the platform where we are going to create some service request types and coordinate the execution of actions in Salt through Salt API. But we understand that any ITSM tools that is available today in most of corporate environments could be adapted and adjusted to achieve the same results. In the past, you have been working also with ServiceNow, and we have apply same capabilities to ServiceNow too. In this presentation of today, you are demonstrate how you have achieved this kind of integration to optimize business process using South. Uh, it's important to note that each one of the tools that we have listed here has its own strengths and weakness. So we understand that all those weaknesses could be circumvented in a way to accomplish what you need to do with automation, but you need to understand how are the limitations of these tools to adapt correctly to our proposal. So on the next slide, Lucas, you talk about the technology that you have created to this in the demonstration of the approach for adding the workflow approval.
Okay, so Cleber told you about the scope of the issues we faced, and I will talk about the solution that we came up to integrate Salt with a service management process using Jira. So let's take a look at the tools that we use for this project. First, of course, we are using Salt project for automation. You're all probably already familiar with it. We also set up Salt API to provide access to Salt, Salt Master from our integration servers. And we also used a library called Pepper. It's official from Salt to communicate with Salt API. And for service management, we are using Jira as a service management tool for our workflow approvals. And for the integration, we are using Python and Flask to create a simple web API. It will act as a bridge between Jira and Salt. And this is the interesting bit, because that's what makes everything work together. Besides these main components from the previous slide, we are also using Docker just out of convenience to house our integration and database. For persistence, we are using Postgres, a Postgres database to store a list of all GNOME minions, all the packages that are available for installation, all the packages that should be installed on certain minion. And for auditing, we also store all the requests made. And we are also using Unicorn and Supervisor inside Docker just to set up our Flask service and our containers. It's important to notice all the code for the solution is hosted publicly on GitHub. You can find everything you need there to spin the solution on your own and check it out by yourself. There is also a document explaining the important bits and how to configure Jira to work with this solution. Also, you don't need to copy it right now. The link will be available at the end of this presentation. And okay, so let's take a look at how the architecture of our solution works. So here you have Salt with its many minions. And you have Jira on the other side, where service management requests need to be approved. So to connect these two, we made an integration. So this integration acts as a bridge between these two, and we have our little Flask API connected with a Postgres database for persistence. And every once in a while, the process, maybe through a cron job or maybe through an automation in Jira, whatever, the Flask integration will populate fields on Jira. So it will ask Salt about all the minions that it knows and all the packages that are available to install on these minions. And using this data, it will populate some tables in Postgres, and then it will populate field options on Jira. So we can use them to bridge screens And these screens can be used to create requests to install packages or reboot minions, whatever. Yeah.
I think that one point here that is important to make clear. We have created three scenarios to demonstrate. And the first is going to be how we could automate the rebooting of servers, so Windows or Linux. The second, how we could request installation of packages in specific versions for Linux, and the same for Windows 2. So these three scenarios was you be mapped as service requests in Jira, but we understand that many other aspects of demands in the infrastructure could be created in the same way and adapted accordingly to achieve this kind of automation.
Thank you, Cleber. And yes, I will talk about more in detail about these three scenarios later. But I also want to mention that it isn't limited to these three scenarios. You can implement your own functions in the integration. And also, I saw a question on chat from Carl. Carl asks, are there native Souch APIs to pull jobs? And the answer is yes. So you can set up a Souch API on the Souch master. And Souch API is basically an API to call Souch functions through an API interface. And in this case, we're using Pepper to call this API, but you can use basically anything. You can use curl and any other library that's available for you in your language. So yes, you can pull jobs through the native Souch APIs. And specifically, you can do this through the wheel module. So yeah. Going back, so every once in a while, our integration will ask Souch about the available packages and push these options to Jira. And then in Jira, whenever a user wants to, for example, reboot a machine, that user can create a service request, and this service request ticket needs to be approved by a team. And after this ticket is approved, and that can be configured in many ways in Jira, depending on the needs of the client, of the customer. So whenever this ticket is applied, Jira has some automations that will pick up the change, and will send a request to the integration, asking the integration to run a certain job on Salt, for example, to reboot a set of minions. The integration will then, for auditing, insert all the request data in Postgres, and then run the appropriate job on Salt. Whenever the job is run successfully, Flask will insert the data back in Postgres, and then update the issue status on Jira. So even if the job can't be run for, I don't know, there's some failure or something, the integration will update the issue to match and tell the operators that there was an error running the job. So everything that needs to be changed will be done by updating the issue status on Jira. So let's take a look at the three scenarios that Cleber was talking about. So the first one of them, the simplest one, is the service to reboot minions. You can implement more as you need, but this is very simple. When a minion needs to be rebooted, the user can basically create this services, select the minions that they want to reboot, and after this request is approved, the reboot will run immediately. There it is possible to schedule this reboot, but we didn't implement it. But it is possible to make it more complex. It just needs a bit more implementation. And for Linux minions, we can manage packages for Linux minions. In this one, you can schedule the installation or removal of a package after a certain date and time, and it will occur automatically without any human intervention. You can either install a specific version of a package, or you can ask to remove it. And another advantage is that you can revert the installation. So suppose after the installation, a package starts causing problems in the system, you can revert this change, and it will automatically contact the integration, and the change will be reverted. So the package will go back to the previous installation, the previous change. There's one limitation to this that we will talk about later, but basically you can revert the installation and you'll go back to the state that it was before. And it doesn't matter if you reinstall the machine on a high state, all the packages that were set to this minion will be reinstalled. And for Linux minions, we are using the stage functions package installed and package purge. And the same happens with Windows minions. So there is another separate request for Windows packages. And this one is basically the same thing, except that we are using Chocolate this time to handle packages, manage packages. Okay, so that's all the theory. So let's take a look at how this works in practice. Give me a moment to change the presentation. Okay, so here we have Jira. For those of you who don't know, Jira is basically, think about it like a issue tracker, but it's much more. It's made for service requests. So here we can create a service request, and here are all the minions that I can request it to. So I want to reboot, let's say, minion 2, and minion 4. I'll give it a title.
It's important to say here that Minion 1, 2, 3 are Linux and Minion 4 is a Windows server.
Yes, thank you. Yes, and I have them open here. So Minion 1, 2, and 3 are open using SSYS, SSH, and Windows is open using RDP for interface. So what I can do is, let me minimize this window so we can see all the minions. So let's select minion 1, 2, and 4. Give it a title and create our issue. Now, one interesting thing to see is how the workflow works. Let me maximize this. So the workflow for this type of request, sorry, not this one. So this is the workflow for this type of request. Basically, we have an open issue, and we can close it, or we can request approval. Now, on this step, after the issue is approved by the team, or it can be declined, but if it is approved, it will automatically be sent to the integration, and we can see this happening here. And if it fails, we can retry, resend the request, and if it succeeds, it will wait for the job to execute, and then it will be automatically transferred to complete. So let's try. I went to requesting approval. I don't know if I will receive the email instantly, This one is from a previous test. I checked this morning and it was taking a while to receive an email. But basically, every time there is an approval request, I will receive an email. So that's also interesting. But okay, let's minimize this and take a look at the integration. Okay, so I approve it. You can see that I already received the request, and it finished it with 3 successes. And you can see that the connection was closed on minion 1 and 2. There was also the Windows minion, but since it was in RDP, it automatically closed the window. Let me open it again. That's a shame. I wanted to show the reboot process. Okay, so it's back up. So yeah, basically this one just reboots the menu. It's showing sending to integration, but if I refresh the page, it should be completed. Yes, completed. So this all happened automatically, and there was no need for human intervention. So everything could be done through a service request on Jira, and that's really powerful. Let me minimize this. So let's take a look at package installation. Sometimes Jira doesn't load the pages correctly. I don't know why. Okay. So let's create a service request to install a Linux package. I don't know what we can install. Let's see. Let's pick a pretty light package, ACPI ID. And you can see that we have, this one only has one version, but if it had more versions available for installation, it will show here. And we can also select to remove the package, which will purge it. So I want to install this package, and we can schedule a date. I will put in the past so we can see the installation. And before installing, I want to do something. I want to go here. Sorry, I need to access the machine again. And I want to check if the package is already installed. So you can see that APC ID is not installed currently. So let's ask it to be installed. Install minion 1 and 2. Okay, we have our ticket. For this kind of request, we have a separate workflow that allows us to revert the request. So if I check here, let me maximize the window. And it's basically the same as the previous one, except after it's completed, we can ask for a reversal, and it goes through the same process of approval. And after being approved, it will be sent to the integration and reverted. I will show you later how this looks in the database. So let's minimize the window and ask for installation. Should see a window soon. Okay, I will approve the change. And you can see here the integration doing its job, and it finished it with 2 successes. Now, it's important to mention that this installation happens asynchronously. So if I come here and check the installation, it will probably not be installed yet because the salt job is still running. I could check this on the salt master to check which jobs are running. And it will probably be finished by now. Yes, state apply, it finished. So if I come here, it's not installed yet. Interesting. Another thing you can do is here and and we can check the history, see what's happened. So we have this command. Huh. Interesting. I don't know why it didn't install the package. Do you have an idea, Cleber?
I think that the name is ACPID. It's not APCID.
Oh, sorry. Let me copy. So that was it. Sorry. Okay, so we can see that package installed, and so now I
It's
want.
important that it's important that you can see in the history logs of APT that the software was installed.
Yeah. Here.
Exactly.
Okay, so another thing I want to do is revert this installation. It won't work, and I will explain later why. But let's remove the package. Let's create another. Let's create another request. This time I want to remove this package, and I will type it correctly this time. CPAD. This time I want to remove it from both these menus. Let's approve it. The job might take a while to run. Let's check. Okay, so it's trying to purge ACPID, and it's not installed anymore. Now, if we go to the database, we can check exactly what is happening. So here we can see that I requested for both these minions to install this version of ACPID, and then I asked to remove these packages. Now there is a field called reverted, and if I go to Jira, let me refresh the page and do the same process, but now I want to revert this installation. I will approve the change. It will be sent to the integration. And now, if I come to the database, it will show as reverted. So now, based on the query that we are doing to select which version should be installed, this installation will be ignored. So it will pick up the latest valid state. So it will pick up this version. And now the package should be installed again. Yes. So if you come to Jira now, it will show that it was reverted. Now, there is a limitation to this, and I will talk more about it later. But basically, we can have entire history of what should be installed on each minion. And then if that minion gets reinstalled, when it comes back up and high state picks up that minion, it will reinstall with all the changes that it needed to have installed, all the packages that it needed to have installed. We can also show that it works for Windows. So let's create a change for Windows. Let's install Firefox. Now, before I approve this change, I want to come here. List all the packages that are installed. Well, we can see that Firefox is not in the list. So now I will come to the change, I will approve it. We can see the integration doing the installation. And if I come here, after the job finishes running, let me check. Yes. So now we should have Firefox installed. Yes. Reversal works the same way with Windows. I won't show it because we are a bit short on time. So let's go back to the presentation, and I want to talk about the limitations of the integration that we made. Okay, I hope you all can see. So let's talk about the limitations. So in implementing the solution, we came across some annoying limitations that we think is worth mentioning. First one is that Jira has a limit of 10,000 options per field. And as you can imagine, we can easily go over this limit with the amount of packages and versions that we need to serve. So that's very annoying. Another issue is that Jira can't read a list of options for each field on the fly. Otherwise, we could feed it all the options through a web endpoint in your integration, and we wouldn't need to populate the fields in Jira every once in a while. And there's also no field type that allows us to have cascading options with 3 or more levels. And if that was possible, we could show packages that are only available on a specific minion. And that limitation is exactly why we needed to create two separate requests, one for Linux and one for Windows, because we can't separate packages based on Windows and Linux minions. And then we had to create two separate fields to separate the packages for each system. That will also be an issue if you have, for example, minions running Ubuntu mixed with minions running SUSE, for example. So you have two separate package systems, package managers, and you can't mix both of them on a field with only two levels of cascading options. We can select the minion that we want to install and then select a package based on that minion. Keep in mind that all these limitations are Jira limitations specifically. We have, like Cleber mentioned before, implemented the same integration before using ServiceNow, which was able to populate fields using web requests. So basically, when the page loaded, we made the request from ServiceNow to fetch the options that should be presented. And that solved basically all of these issues. I'm not sure if Jira has an extension that allows fields to be populated from a web request, but I'm pretty sure that I saw an extension that allowed that created a field with 3 levels of cascading options. So if you're interested in developing this further, you could probably try to work around some of these limitations in Jira by using extensions. The only one I don't know if it's possible to circumvent is the limit of 10,000 options for each field options. So where do we go next? All of this is just a minimal product, just to show that Salt can easily be integrated with a service management tool. And just to give an example of what can be done, if you want to run this solution in a production environment, however, you will probably want to make sure that make some changes to make it more robust and reliable in production, and probably to add more functionality to it. Like I mentioned, we only implemented reboots and package installation, but you can do basically anything that Salt can do. You just need to create an endpoint to make the requests. It's pretty easy to implement, so there is no secret. All the code, if you want to study it, is on GitHub. Another point of improvement is that in the way that it's working right now, every now and then we need to sync the options and populate the field options on Jira. And that has an issue with the current implementation, in that all the options are being deleted from the fields before being populated again. And that takes a long time to make each delete request. So it's much smarter to check which options need to be deleted first and which ones need to be created, and to avoid unnecessary calls. So basically a patch logic, but we didn't have the time to implement this for this presentation. Another thing that we didn't implement was a way for reboots to be scheduled, but that can be easily done. And another interesting thing that I suggest would be a way to guarantee that the reboot was actually executed. It's very simple to do, but will require some implementation using salt states. Another way that you can improve reboots is by using a reactor to let the integration know when to update the ticket status on Jira. So you basically can update the ticket saying, okay, these minions were successfully rebooted. And I mentioned before that the revert functionality for package management has an issue. And that's basically when you want to revert all the changes that were made. In that case, since we don't have the information about which package was installed before and which version it was at, if you revert all the changes, the automation has no way to know what packages to install back. That also can be easily solved by storing the initial version of the package before applying the first change. So if you have ACPIG on version, for example, 2, and you make a change to install version 3, and you reverse the change of version 3, if you store the initial version of 2 on the database, you can revert to that package version when you revert the change. Right now, that's not done, so that is impossible. And finally, the integration is currently marking tickets as completed as soon as the job is requested to Salt, since it's running the jobs asynchronously. So we don't have a very accurate information about when the job was actually successfully finished. So that's also a point that you might want to change, and to make sure that, for example, a reactor or some kind of loop tries to check when the job finishes and what was the status, so you can properly show on Jira if the ticket failed or if it was successful. And that's it for this session. I thank you all so much for your presence, and I hope you enjoyed our take on how to integrate Salt with Jira for service management with an approval workflow. And I think we have about 5 minutes left, so we will be open for questions. And also,
great. I'll keep an eye on.
Okay.
Oh, go ahead.
I was just going to mention that if you have any questions in the future, feel free to hit us with an email. And if you want, the GitHub link for the code for this presentation is on GitHub. So feel free to access it. It's public, and have fun with it.
We understand that you have many work to improve this code, but the idea presented here, we understand that covers some gaps that you have connecting automation with business process, and we understand that could be an idea that could be used for many other user cases.
Okay, well done. This was such a great presentation. Thank you both. You'll see everyone in the top right corner. There's an option for Q&A, a tab, and this actually allows you to ask a question and upvote it. It looks like we have Robert Dale requesting to ask a question, if that's all right.
It was already answered in the chat, but just to
Okay.
mention, Flask is open source. I think all of the technology used here is open source. So yeah.
And all the code that we have created here, even some aspects of configuring Jira, is available on our GitHub, so that the community could use that, could extend that.
Okay, and it looks like you have shared the link already to the GitHub repo as well.
Just something that I want to mention. Basically, everything that you can imagine, you can basically do with Salt by implementing an integration that uses the Salt API. So if I have any idea, anything that you want to integrate Salt with any tool, it probably can be done through an integration using the API. Salt is very extensible. It's very easy to adapt to any scenario that you want to implement, and that's one thing that I really love about Salt. Uh, it's really easy to integrate with if anything that you can imagine.
It's looking like we don't quite have any other questions posted yet. Just keep an eye on that for a few more minutes.
Okay.
Uh, Answering Victor that asked which parts of implementing it were the hardest. The hardest part for me was communicating with Jira. Jira is a bit, how do I say? It's not very extensible, and the API is a bit confusing. It's not very properly documented, and there's a package, a library for Jira on pip, the Python repository, but it's not very robust, and I had to make something changes to make it work properly with Jira, and also uh, to make some reliability changes, such as, for example, it's very slow to run each individual delete request. So I had to use a multi-threaded approach to make multiple requests at once, and that was giving me a lot of too many request errors. So I had to implement some exceptions to catch these errors and to make it reliable enough and fast enough to run these commands, these requests.
Okay, any other questions before we wrap up today?
If there's anything that you guys want to see, for example, some Jira settings, uh, I can show them. There's no issue. But just to mention, there's a PDF file on the GitHub repository explaining basically all the important automation settings on Jira. So you can replicate the settings on your own and make it work for you.
Thank you both for sharing today, Cleber and me, because this has been a really great presentation. I hope the rest of you joining are excited and that you're enjoying SaltConf so far. Looks like we've got a lot more ahead of us, including a networking hour for the next hour or so, and then opening again with a couple different options for different sessions.
Thank you. It was a
Thank you.
pleasure to be here. Thank you, everyone, for your presence. It is really enjoyable, and it's an honor to be here to share the session with you.
Thank you. It was a pleasure. And you have any doubts, feel free to reach us through the email. Bye-bye. Thank you.